Bandana, wow, you blow me away every day. All the new stuff that you do. You are an absolutely incredible researcher and hacker and speaker, and so much to learn from you. So thank you and take it away.
Thank you so much for having me here, and I am just as excited. So, welcome everyone to the API Hacker's Guide to the AI Wild West. Now, before we talk about I want you guys to write down in the chat the most the most unnecessary or the most funny application of AI that you saw recently. I want you all to just take a minute to think about how pervasive AI has become in our daily lives. The funniest application of AI that I saw recently was an AI bird feeder and an AI toothbrush. Not sure how those are useful, but I bet they are useful in some way. Anyways, let's talk about AI. AI has been there since the 80s and the 90s, but is only blowing up now because it's all around us now. Whether you would like to use AI or not, it's everywhere. It's in your school systems, it's in your hospitals, it's in your customer support bots. AI is everywhere, but what is AI? AI, or artificial intelligence, is basically a system that consumes a bunch of data, processes it, and gives you an intelligent output. Now, whether that output is actually intelligent would be debatable, but that output could look like a new generated image or some generated text, or it could look like a classification or something that's not entirely newly generated. So that's what AI is. But today we are not at AISecCon, we are at APIsecCon. So let's put the P in AI, and the P here stands for plumbing. So when you connect an AI model to data outside of the data that is been trained on, it uses APIs. Now, an API or an application programming interface is how two software applications communicate with each other or exchange data with each other. So, if an application A wants to share some data with application B, an API is the protocol or the interface through which they would communicate. Now, a fun way to think about the relationship between AI and APIs would be that APIs are the plumbing for AI. And sometimes it does cause a mess, quite like this. But today we're going to walk through the kinds of security issues and the kinds of vulnerabilities that can arise in the relationship between an AI model and an API. Is it possible to hack an AI application with the help of a traditional API vulnerability? And is it possible to go the other way around? Can I actually hack? Can I actually hack an API through a vulnerability that lies in a chatbot or an AI model? That's what we're going to explore today, and I hope you guys are excited. But first, for this AI Wild West, I'm going to take a moment to introduce myself. I'm Bandana, or as some of you might know me, HackWithHer. Independently, I am a large language model security researcher, and large language models are just a type of AI models that understand and generate human like language. So, a common example of a large language model would be ChatGPT or any sort of chatbot. Now, I'm also a security research engineer at APIsec, and I'm working on a whole bunch of stuff. I'm making and breaking APIs, and it's just been really fun. I'm also the cybersecurity lead and a board member at the United Nations Dynamic Teen Coalition, which is a part of the Internet Governance Forum. I'm also an ambassador for the US National Initiative for Cybersecurity Education, and I've dabbled a bit in bug bounty hunting and vulnerability disclosure programs through the web applications of NASA, the Indian government, the US Department of Education, and the US Secret Service. I've also been a guest lecturer to Indian government CISOs on open source intelligence and social engineering. And fun fact, it's actually my birthday tomorrow. In my home country, it's my birthday today, so I just turned 18. But enough about me. Let's get back to the relationship between AI and APIs and how to hack both of them. So, we talked about pen, we talked about AI and what AI is, and I believe at its core, all AI is just statistical models and neural networks. But we also talked about APIs and AI applications. So we talked about pen, we talked about pineapple, but how do the two of them work together? So we're going to go into a little bit of depth here through an example. So if I ask Siri right now, hey Siri, what is the weather like today? What Siri is going to do is Siri will use something that's called natural language processing, which is something that AI knows how to do. So Siri will process my request, and since Siri can't just go outside and check what the weather is like, Siri will query the API for the weather forecasting service and fetch that data. Now, after that data has been fetched, Siri will translate it back to me in human language. So that's how, in essence, the relationship between an AI model and an API call works. Now, the thing is, when that AI sits between the human and the API, that's when security issues start to arise. Now, these little icons here that I have flagged are actually the potential attack vectors that we could have. Let's take a moment to see how this would look in practice. Let's see how it could be possible to hack an entire AI application, and that to a very popular AI application, through a traditional AI API vulnerability. So I hope you guys are familiar with Meta, Instagram, WhatsApp, Facebook, whatever. I think most of you might be familiar with Meta services. And in some way or the other, we've all been exposed to Meta AI, whether it's in our chats, whether it's editing pictures, or whether it's generating pictures. So let's talk about a hacker who just liked exploring Meta AI's API. So behind the scenes, Meta AI actually uses a GraphQL API for its client-server communications. Now, a researcher was just playing around and he noticed that there's a certain media set ID. I've put it in a box here in pink. And if you and this media set ID is like a user ID, or in school terms, it's like a roll number for you. It's a unique identifier that identifies a certain user. Now, the researcher noticed that if you actually change this user ID to another predictable value, like another number, say 1, 2, 3, 4, 5, 6, you get somebody else's generated pictures. Isn't that interesting? Now, in now for those of you who are familiar with bug bounty hunting and API security, this is actually called an IDOR vulnerability, or an insecure direct object reference. This is a really prevalent, and in most cases it's a critical vulnerability, because it allows for account takeover sometimes, it allows for viewing sensitive data for others, like it did in this case. So in an IDOR vulnerability, a hacker intercepts an HTTP request or an API call, tweaks the value of a certain parameter to some predictable value, and the GraphQL API then serves the data for that particular user ID value, and the AI, just being an innocent player there, the AI model actually returns somebody else's generated pictures. So isn't that interesting? Now, those of you who are actually familiar with this stuff might be thinking, so AI models an AI model is just another service running on APIs, right? Correct, but to an extent. Securing AI native APIs is something that takes a different turn, because AI models actually come with their own baggage and their own specific set of threats. So the AI API attack surface consists of your usual API related threats like IDORs, SQL injections, XSS, that type of stuff, and also the threats that the AI model poses to the API. Sometimes it's even like the AI model's vulnerabilities serve as an entry point into the application itself. For example, there have been incidents where people have been able to trigger classic API vulnerabilities through prompt injection. Now, for those of you who don't know, prompt injection is a type of vulnerability that's primarily there in language models, where you type in a certain malicious prompt and it does an action for you that it's not supposed to do, in simple terms. So, enough theorizing. Let's take a look at how this would look in practice, and let's take a look at a very unfortunate incident where both the API and the AI were vulnerable. So, this is Lenovo, and meet Lenovo's Lena customer support bot. This is like a virtual assistant chatbot that you can talk to. Now, the thing is, here a researcher found that if you inject a certain prompt injection, it might trigger cross site scripting, which is XSS and which is another classic API vulnerability. Now, the thing about XSS is that it can be escalated to hijack somebody else's accounts and somebody else's sessions. And so it's just a really impactful vulnerability in itself. Now, this vulnerability could actually be triggered through the chatbot itself. So you see how the chatbot actually served as a weak link in the entire application. Now let's talk about the exploit chain for this. So the payload was the prompt injection payload, and the attacker the attacker just added a classic XSS payload inside of a prompt. Now what happened was the Lena chatbot actually processed it as it is and reflected it somewhere in its output. Now because that chatbot was vulnerable, it did not have proper secure output handling. Now, another layer to this goes when the API was vulnerable too. And somewhere it got lost in translation, and the payload was actually reflected on the front end, which triggered the cross site scripting vulnerability. Now, as I mentioned, cross site scripting is not just something that triggers something in the front end, it can be used to hijack other sessions as well. Now, I hope you can see how both the AI model and the APIs can be weak links to each other, and how the vulnerabilities just go both ways. Now, let's talk about why this vulnerability actually existed in the Lenovo Lena chatbot. Let me tell you an interesting fact. This chatbot was actually built on top of OpenAI's GPT-4. Now, you might be thinking, so does that mean OpenAI's GPT-4 is vulnerable to prompt injection in that sense? Not necessarily. The vulnerability actually lied in the sense that it actually lied in the way that AI model was integrated into Lenovo's application. So this was just a big old recipe for disaster, improper AI output handling, plus a vulnerable API that caused XSS. It was just a big old recipe for disaster. So we talked a lot about attacks here, and we talked a lot about how to hack these APIs. But why can't we just use a common web application firewall like we do with a lot of API related vulnerabilities? Why don't classical security measures and traditional security measures for APIs not work for AI specific APIs? Now, let me introduce you to a new concept on AI that's called non-determinism. Now, some AI models are non-deterministic, and most of them are non-deterministic in the sense that if you give it a certain input, it's not always going to give you the same output. If you ask ChatGPT a question once and twice and thrice, it's going to give you different outputs every single time. So, traditional API testing was predictable and it was spec driven, and you know that if you enter the wrong password somewhere, it's actually going to write wrong password. You know what that wrong output looks like. But for AI related APIs, you do not know what that output looks like. Right? So it's hard to filter for entropy. And another thing I mentioned previously was that AI comes with its own baggage and its own set of vulnerabilities. So it's just hard to design tests for those and secure those specifically. But if you carry anything from this presentation, I want it to be these three golden rules. So to secure AI APIs, first you go back to basics. You learn from Meta's mistake and you secure the API. API security already tends to take the backseat in a lot of organizations, and with AI's deployment being everywhere and AI using so many APIs, you need to go back to basics and just secure the API first. Next, test the brain of the application. Adversarial testing for AI models is super important. Input output filtering for AI models is super important. And next, you watch the frontier. AI has evolved so much in the past 6 months that it literally feels like a decade of innovation. So you monitor and you adapt and you repeat. So it's important to stay updated in the field of AI security. So the wild west of AI applications is not waiting for a sheriff anymore. It's waiting for hackers willing to step up and keep it secure. AI is all around us and AI is very visible around us. But and at the same time, APIs are all around us. But the thing is, unlike AI, APIs are not as visible. They usually go unnoticed. So it's important that you secure the API that runs the AI model as well. And that is it for my presentation today. I know this was a really short presentation, but I hope you guys enjoyed. I hope you guys had something new to learn and some interesting little stories. And as always, happy hacking.